Hi and welcome back to my video channel, The Opinionated Science Educator. Today's video is in response to a question I saw on the Facebook Life Science Study Group. It is for grade 12 biology and it relates to genetics and sex-linked genes. The Life Science Study Group on Facebook is an open public group that anybody can join and ask questions and get support from fellow students and so on. And when I find questions like this, I often do answer them. This question says, can you please help me out with this? Explain why males with an allele for color blindness are always colorblind. So this video is going to answer that question. But before I answer that question, I would just like to point a few things out. Sometimes you need to apply concepts you already know to help you understand more difficult ideas. So it's important to make these links to make sure your learning is deep. Now, I'm going to be using the idea of recessive and dominant alleles. Remember, if there is a recessive allele in a heterozygous person, the gene is not expressed, it is masked because it is recessive. Then I'm also going to use the idea of sex determination in humans, which is determined by the presence of a Y chromosome, because females are XX and males are XY. Let's start by looking at dominant and recessive genes. Remember, you can either be homozygous for the dominant gene or homozygous for the recessive gene, and that's when the recessive gene is expressed. If you are heterozygous for the recessive gene, it is not expressed. So I'm going to do a cross between a homozygous and a heterozygous allele. So cleft chin is an example of one of the genes that are expressed through that dominant or recessive gene, with the cleft chin being dominant and the smooth chin being recessive. So if I have a cross between a male who is homozygous for the dominant gene and or homozygous and the female is heterozygous, in other words, she does have the allele for a smooth chin, putting them crosses into a Punnett square and crossing them, you will see that they will have a 50% chance of having children with the dominant cleft chin and 50 with the heterozygous cleft chin. None of their children will have a smooth chin. Now let's look at sex determination. Remember, male is determined by the presence of a Y chromosome. A male is XY, a female is XX. So again, let's look at what the chances are. So now going through the same process of doing the Punnett square. So let X represent the X chromosome, Y is the Y chromosome. If a man who's XY and a woman who are XX have children, what are their chances of being a boy? So in the male sperm, through meiosis, 50% will have the X chromosome, 50 the Y, but in the female ova, it will all be XX. So doing the Punnett square, male on the top, female on the bottom, bringing the crosses together, you will see that there is a 50% chance that the couple will have a boy. So that's a 50% chance that they will have a boy. So let's look at that again. This time I'm going to put the two crosses together so that we can compare them. So let's look at the recessive gene. There's one of the recessive alleles. So 50% of the offspring will be carriers for that. None of them will have smooth chins. In terms of sex determination, we saw that 50% would have the 50% chance of them being boys, 50% chance being females. So to summarize, when there's only one allele of a recessive gene and a couple have children, that recessive gene is not expressed in any of their children. But 50% of their children will carry the recessive gene. And with sex determination, the presence of just one Y chromosome in the crosses results in a 50% chance of the couple having a boy because of just the presence of the one Y chromosome. Now let's look at sex-linked traits. This is the normal way to represent sex-linked Punnett squares, but I'm going to be using a colored cross for the allele. So sex-linked traits are traits that are where the genes, or the alleles should I say, are found on the X chromosomes. So one example is red-green color-blindness. So here, males and females do not have the same sex chromosomes. Boys only have one X chromosome. So if that chromosome carries a gene for color blindness, they will be colorblind. Girls have two X chromosomes. So a girl can have one X chromosome with the colorblind gene and one X chromosome with the normal gene for color vision, in which case the color blindness is recessive and the dominant gene will mask the recessive colorblind gene. So, as I said, let X represent the dominant gene, and I'm going to use a red X to represent the recessive gene on the X chromosome. So if a man, XY, marries a carrier, what is the chances that their sons will be colorblind? So let's have a look at that cross. Okay, so firstly, in terms of the gametes during meiosis, the sperm will have one X chromosome, one Y chromosome. There's no color blindness allele on his chromosome. The female will have one X chromosome that is for normal vision, one X chromosome for the recessive gene. So doing the Punnett square cross with the XY male, XX female, you can see that because of the fact that the one X chromosome has the allele for color blindness, one daughter will be a carrier and one son will be colorblind. So there's a 50% chance that they will have a boy and a 25% chance he will be colorblind. And so as you can see, because the sex is determined by the presence of a Y chromosome and the mother is a carrier, then one son out of every two will probably be colorblind, and that is how I've answered your question. I hope that that helped. So I hope that you found that response useful and that it answered your question fully. Until next time, this is the Opinionated Science Educator saying be safe, take care, and I'll see you soon.